All right, let's take what we just talked about and put it into practice to actually solve rotation angles. So, consider an angle theta in standard position with a point of 1 and the square root of 3 on the terminal arm. I know that that means that this is going to be 1, this is going to be the square root of 3. Sorry, no, square root of 1, square root of 3. I can say that r squared is equal to 1 squared plus the square root of 3 squared r squared is going to equal 1 plus 3, r squared is equal to 4, and r is going to equal the square root of 4, or nice happy round number of just 2. Now I know that it asks us to do that for part B, but I typically jump right into there to find what all the values are right from the get-go. For part A, it says show that the value of theta is 60 degrees. Well, we know that tan of theta is equal to the opposite, or the y value, divided by the adjacent, or the x value, which means that the angle, when we isolate it, is equal to tan to the negative 1 of that ratio, which is in fact 60 degrees. So we know that x is 1, y is the square root of 3, and r is going to be 2. So sine of 60 degrees, because we know it's exactly 60 degrees, solving up here, is going to be exactly root 3 over 2, or 1 over 2, or root 3 over 1, which is a fraction we can reduce down to just the square root of 3. That is the exact value of sine 60, cos 60, and tan 60. Now they reflected that in the y-axis, where we can see that it was reflected from here over to here, but the distance between these points are going to be the same. And the height is going to be the same. So all that changes with that reflection is my x becomes negative. When I do a reflection, the reference angle stays the exact same. The rotation angle, now with a reference angle of 60 in quadrant 2, is going to be 180 minus 60. That's going to be 120 degrees. Well, I know that the other values are going to stay the same. So I have r is 2. I have my x is negative 1. And I have my y is at the square root of 3. So my y value divided by my r value is just root 3 over 2. My x value in this quadrant is negative, and my r value is still just 2. And my y value, root 3 divided by my x value of negative 1, is just the same as negative square root of 3. it went ahead and reflected it again. And so now it's going to reflect downwards where x is negative and y is negative. The reference angle, because we're still just reflecting, hasn't changed. It's still 60 degrees. The rotation angle in quadrant 3 is going to be 60 degrees more than 180, or 240 degrees. And now we can see that with the negative y value and x value, my r is still just 2, because when I take the square root of something squared, it's the positive version of what that is. Then I'm going to have negative root 3 over 2, which is just negative root 3 over 2. Negative 1 over 2, which is still negative. And for tan, I have negative root 3 divided by negative 1, and the negatives cancel out, and I have positive root 3. We're going to reflect it one more time, and when we reflect it into here, then the next reflection is going to make that x value positive again, but the y value still remains negative. Remember, my reference angle hasn't changed at all, and if it's in quadrant 4, my rotation angle is going to be my reference angle less that full 360, or 300 degrees. What do we see in here? My x is now positive, my y is negative, and my r is still positive. So I have a sine value of negative root 3 over 2. I have a cos value of positive 1 over 2. And I have a tan value of negative root 3 over 1, which is just negative root 3. When we break it down, the trigonometric ratios for angles between 90 and 360 are either the trig ratios of the reference angle or the negative of the trig ratios of the reference angle. So the numbers in all of these parts stayed the same. If I look at sine, it was 3 over 2, or 3 over 2, or negative root 3 over 2, or negative root 3 over 2. Same number twice, it was just 2 times it was positive and 2 times it was negative. The same thing was true with all of them. There was 2 of the ratios were positive and 2 of the ratios were negative. So if we break it down in this chart, if sine is always y over r, cos is always x over r, and tan is always y over x. That's true in all the quadrants. Y over r, x over r, y over x. Y over r, x over r, y over x, and finally y over r, x over r, y over x. We know, because we solve the r value using Pythag, where we have to square things and then square root it, it's always going to be the principal square root, which means that the r value never actually changes. We also know that in quadrant 1, both x and y are positive. So the nice thing about quadrant 1 is that everything is positive. And a positive divided by a positive is always a positive. When we go to quadrant 2, my y's remain positive, but my x's become negative. Now for sine, a positive divided by a positive is still positive. But a negative divided by a positive or a positive divided by a negative are both going to be negative values. When I go to quadrant 3, both my x and my y are negative. And we can see that for sine and cos, a negative divided by a positive is going to give me a negative. But for tan, a negative divided by a negative is going to make it positive again. And when I get into quadrant 4, my x's are positive, but my y values are negative. So I have, for sine, a negative divided by a positive is negative. For tan, a negative divided by a positive is negative. But for cos, both my x and my r are positive, and that's going to give me a positive. And from there we can see that all of them get to be positive twice, and all of them are going to wind up being negative twice.